Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic change of subjects. This is the first video on change of subjects. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to make a variable the subject in an equation. And you should be able to substitute known values into a formula. These are our main objectives for this topic. Let's learn more about change of subjects. Let's consider these formulas or equations. The first one is E is equal to mc squared and the second one is A is equal to pi r squared. Let's concentrate on the first one for now. We can see in this equation that E is on the left hand side with no variable attached to it. That is, E is alone. On the right hand side, we have m and c squared. Because E is alone with no variable attached to it, E is said to be the subject of the equation. In the second equation, we can see that A is on the left hand side alone with no variable attached to it. But on the right hand side, r squared has pi attached to it. Now, because A is on the left hand side alone with no variable attached to it, A is said to be the subject of the equation. Now, what is change of subject? What change of subject means is that we can rearrange these formulas. We can rearrange them such that in the first case, M becomes the subject instead of E. So we will rearrange it such that M will become the subject instead of E. Now that's what we are talking about. You can see that in this new equation here, M is now on the left hand side with no variable attached to it. But when you go to the right hand side, it is E over c squared. So clearly from here, we have changed the subject from E to M. That is what we mean by change of subjects. We have changed the variable that was on the left hand side with no variable attached to it. We have changed it from E to M. So we have changed the subject from E to M. In the same way, you can also change the subject from M to C. We are just considering M as an example for now. In the same way, in the second example, we can change the subject from A to R. If you change the subject from A to R, we are going to get R is equal to square root of A over pi. Don't worry if you don't know how to do this. That is what we are going to do in this series of videos. So here too, we've changed the subject from A to R. Now when we do this, we say that we have changed the subject of the formula or the equation. I hope you understand the concept of change of subjects for now. Now let's move on. To change the subject of an equation, make sure that the terms containing the new subject are on the one side of the equation and the other terms are on the other side of the equation. So to change the subject of an equation, you have to make sure that all the terms containing the new subject are on one side and the other terms are also on the other side. Now, what do we mean by a term? In the video on Introduction to Algebraic Expressions, we explain what a term is. I'm going to explain it again in these videos, but if you want an in-depth understanding of it, go and watch the video on Introduction to Algebraic Expression and you understand what a term is. So in order to change the subject of an equation, what you need to do is that make sure that you group all the terms that have the new subject on one side, either the left or the right. Then you group the other terms on the other side. The principles involved in changing the subject of an equation or formula is similar to the principles used in solving linear equation. What this statement means is that how we are going to change the subject of a formula or an equation is similar to the way we were solving linear equations. So we are going to do it in a similar way, almost the same way. So if you want to really understand change of subjects, I suggest that you watch the videos on solving linear equations. We are going to change the subject of a formula or equation the same way as we were solving linear equations. So if you watch those videos, you are going to understand change of subject very, very well. So I recommend that you watch the video on introduction to algebraic expressions. You also watch the video on linear equations and make sure that you understand them before you watch these videos on change of subjects. Sometimes after changing the subject of a formula, you may be asked to substitute known values of the variables into the new formula. Now this is what this means. You can see that in this case, we change the subject from E to M. Sometimes after changing the subject from E to M, you will be given values for E and C. Then all you need to do is to substitute them into this new formula. So where you see E, you put the new value. Let's say that after changing this subject, they tell us that, let's say, calculate for M when E is equal to 2 and C is equal to 1. All you need to do is to, wherever you see E, you change it and you replace it with 2. Wherever you see C, you change it and you replace it with 1, and you'll be able to find the new value for M. Thank you for watching this video on introduction to change of subjects. See you in the next video where we will begin to learn how to change the subject of an equation. We are on the topic change of subjects. In the previous video, we looked at introduction to change of subjects and we explained the concept of change of subjects. In this video, we are going to study how to change the subject of an equation or a formula. Just as we did for linear equations, we are going to group the equations or formulas that will be changing their subjects into types. We will consider the first type in this video. The first type, we have equations without fractions. Equations or formulas without fractions. So in these equations or formulas that we'll be considering, there are no fractions in them. How do we change the subjects? We have 4 examples here. In each case, we are to make X the subject. We will consider the first 2 in this video, then we'll consider the other 2 in the subsequent videos. So let's take the first question, which will be our first question for this video. Make S the subject in V is equal to U plus VA. So our question is V is equal to U plus, V is equal to U plus AX. That's our question. V is equal to U plus AX. And we are supposed to make X the subject. Now you can see from here that in the previous video, we explained that in a formula like this, V is the subject. So we have to change it in such a way that X becomes the subject. That is our goal. Now what do we do? In the previous video, we saw that if you want to change the subject of an equation, make sure that the term containing the new subject, the term containing the variable that you want to make the subject, stands alone on one side of the equation. Now this is what we mean. Terms in an equation, we explained in the video on introduction to algebraic expressions that terms in an equation are separated by either addition or subtraction. So in this equation here, we can see that because V stands alone like this, it is one term. U also stands alone, it is one term. Now A and X are together, they also stand alone, so it's also one term. So V, U and AX are separated by addition, so U is one term and AX is also another term. So we now know what a term is. The goal is that we have to make the term containing the new subject, which is X. X is what we want to make the subject. You have to make the term containing the new subject stand alone. The term containing the new subject in this equation here is AX. So we have to make sure that AX stands on one side of the equation. Then all the other terms will be on the other side of the equation. Now because AX is already on the right hand side here, I'm going to keep it here. Then I will take all the terms to the other side. With AS on the right hand side here, the other term is U. So I will take U from this right hand side and bring it to the left hand side. We learned in linear equations that whenever a term crosses the equal sign, it takes the other sign. Whenever a term crosses the equal to sign, it changes the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. So u is positive here. When it crosses the equal to sign to this side, it becomes negative. So we are going to have v, which is already here, minus u, because u is positive here. So when it crosses to this side, it becomes negative. Now we have the term containing the new subject, which is x, on one side. So it's on the right hand side. The other terms are on the left hand side. This is what we want. In linear equations, we said that when you get to this side, if you want to make x the subject, or if you want to find x, what you do is that you divide through by the variable attached to x. You divide through by the variable attached to x. Here, the term attached to x is a. So what you do is that you divide both sides by a. So you divide the left hand side, which is v minus u, by a, and divide the right hand side, which is ax, by a. So from here we can see that a will cancel a. So this a here will cancel this a, giving us x. And the right hand side, the left hand side, is going to be v minus u divided by a. So we have v minus u divided by a is equal to x. So you can see that x is equal to v minus u divided by a. So you see clearly from here that we have been able to change the subject from v to x. That is our main goal in change of subject. We change the subject from v to x. Make sure that the term containing the new subject is on one side, then all the other terms is also on one side. From there, you simplify. Let's look at the next example. Make x the subject in 7x plus u is equal to vu. 7x plus u is equal to vu. Now what do? You identify the term with the new subject. The term with the new subject is 7x. Make sure that that stands alone. So I will keep 7x on the left hand side because it's already here. Then I will take u from the left hand side and send it over to the right hand side. So I'll get 7x is equal to vu minus u, because u was positive here. So when it crosses to this side, it becomes negative. Now here, what do? I divide through by the number or the letter attached to the new subject. The letter attached to the new subject is 7. So I'll divide both sides by 7. So 7 will cancel 7. And I'm going to get x to be equal to vu minus u over 7. Once again, I've been able to change the subject of the equation to x. So we have x to be equal to vu minus u divided by 7. Thank you for watching this video. In the next video, we are going to take 2 more examples on type 1 of change of subjects. We are still on the topic change of subjects. In the previous video, we took an example on changing the subjects of equations that does not involve fractions. In this video, we are going to take 2 more examples on changing the subjects of equations that does not involve fractions. So we look at the first example for this video. Make x the subject in ry plus 2x is equal to tx plus 4y. So here's our question. Ry plus 2x is equal to tx plus 4. Ry plus 2x is equal to tx plus 4. And we are supposed to make x the subject of the equation. Now you can see that here we have 4 terms. The first term is ry, the second term is 2x, the third term is tx, and the last term is 4. We have 2 terms containing the new subject. The new subject that we want is x. 2x contains x and tx also contains x. Make sure that all the terms containing the new subject are on one side, then the other terms are also on the other side. What we are interested in is the term containing the new term. We are interested in the terms containing the new term. So the terms we are interested in are 2x and tx. Make sure that you send all of them to one side. Then all the other terms can go to the other side. So this is what I'm going to do. I will keep 2x here since it's already on the left hand side. Then I'll bring tx over. And I'll send ry from the left hand side to the right hand side. So this is what's going to happen. I'll keep 2x here. It's positive. Tx is positive. When it crosses to this side, it becomes negative. So 2x minus tx. 4 was already here, so 4. Ry was positive here. When it crosses to this side, it becomes negative. So you can see from here that I've grouped the terms with the new subject, which is x, on one side, then all the other terms also on the other side. From here, I can simplify. What I have to do here is that I will have to factorize x out. In the video on factorization of algebraic expressions, we explained how to factorize something out. We are going to do the same thing here. So here, we take x out. Since x is the common factor, we take it out. Then we will leave the others in the bracket. So here used to be 2x. Because you've taken x out, the place is now 2. Here was tx. We've taken x out, so it's t. Now, because 2 minus t is a binomial, we are going to put it in a bracket. So that's why x, we are putting 2 minus t into a bracket. We are putting it into a bracket because it's a binomial and it's being multiplied by a single term, which is x. So we will put the binomial in a bracket. We explained this in the video on binomials under algebraic expressions. So x is equal to 2 minus t, and this is equal to 4 minus ry. We get here, what do? We want to make x the subject. You divide by the variable or the letter attached to x. In this case, what is attached to x is 2 minus t. It's the binomial 2 minus t. So what we are going to do is that we are going to divide both sides by 2 minus t. So you will divide the left hand side by 2 minus t. You will divide the right hand side by 2 minus t. And when you do that, the 2 minus t on the denominator here will cancel the 2 minus t on the numerator here, so that our x can stand alone or become the subject. And this is going to give us x is equal to 4 minus ry divided by 2 minus t. So you see that with this, we have been able to make x the subject. Once again, make sure that the terms containing the new subject are on one side, or group those terms, then all the other terms can be on the other side. Let's consider the next question. We have 3x minus ax is equal to 2x plus 5, and we are supposed to make x the subject. Our question once again is 3x minus ax is equal to 2x plus 5. So what do? You group all the terms with the new subject on one side. The new subject is x. That is what we want to make the subject. So make sure that all the terms with x are on one side. We have 3 terms with x. We have 3x, ax, and 2x. Fortunately for us, 3x and ax are already on one side. So what we have to do is that we bring 2x over to that side. So that's exactly what I'm going to do. 3x minus as were already here. They are already here. So I'm bringing 2x over. 2x is positive. When it crosses to this side, it becomes negative. So I'll have 3x minus ax minus 2x. This place is now 5 because I've taken 2x from here. Now let's look at something. We can rearrange the side that we have 3x minus 2x minus ax is equal to 5. What is 3x minus 2x? It is x. So you have x minus ax is equal to 5. So we've simplified 3x minus 2x. In the video on algebra, we explained why 3x minus 2x is x. So x minus ax is equal to 5. Here, what do? Just as we did in the previous example, we factorize x out. Once again, because x is the common factor, we will take it out. So we have x, then into bracket. Here used to be 1x. Because it's 1x, we don't write the 1. So if you have taken x out, you are going to have 1 minus. Here was ax. We've taken x out, so we now have a, and this is equal to 5. We divide both sides by 1 minus a. So we divide both sides by 1 minus a, and x will give us 5 over 1 minus a. Once again, you see that in these videos, we are applying the principles used in solving linear equations and algebraic expressions. All these topics have been explained. So if you have any difficulty, watch those videos and you understand how some of the computations are done here. Thank you for watching this video. on change of subjects. In the next video, we are going to start with the next type of equation. We are going to change the subject of the next type of equation. And in these equations, there are fractions in it. So we will learn how to change the subject of equations that involves fractions. We are on the topic change of subjects. In the previous video, we learned how to change the subject of equations that does not involve fractions. In this video, we are going to learn how to change the subject of equations that involves fractions. So we are on type 2 of equations involving fractions. We have been given 5 examples here. We will take them one after the other. We will solve the first one in this video, and we will solve the other ones in the subsequent videos. So let's take the first one. Make h the subject in v is equal to 4 over 3 pi r squared h. Find h when v is equal to 20, r is equal to 5, and pi is equal to 22 over 7. Leave your answer in 3 decimal places. So let's take the question one after the other and solve it. Let's concentrate on the first part of the question. Make h the subject in the equation v is equal to 4 over 3 pi r squared h. So this is our equation, and it involves a fraction. When the equation involves a fraction, what do we do? The first thing you need to do is to first identify the fraction in the equation, or the fractions in the equation. Fortunately for us, in this equation, there is only one fraction, and the fraction is 4 over 3. So after you've identified the fraction, you have to find the LCM of the denominators. There is only one denominator here, so the LCM is going to be that number. So here, 4 over 3. So the LCM is 3. Okay, so the fraction we have is 4 over 3. So the LCM is 3. 1, you identify the fraction. 2, you find the LCM of the denominators. Here, because there is only one fraction, the LCM is going to be the denominator of that fraction, which is 3. Now, after you found the LCM, you identify the terms in the equation. As we explained in the previous videos, terms are separated by addition or subtraction. In this equation here, you can see that there is no addition or subtraction. It means that what is on the left hand side is one term, so v is one term, and all what is on the right hand side is another term, so all of this is also another term. So we have 2 terms in this equation: the expression on the left hand side, which is v, and what we have on the right hand side. Now, after you've identified the terms, you multiply each term by the LCM. Remember, multiply each term by the LCM. The LCM you found was 3. So you multiply each term by the LCM, and this is what you are going to get. So the first term is v, so 3 times v. Remember, 3 is the LCM, least common multiple. On this side too, this is also another term, so you multiply this term too by the LCM. Now, when you multiply this term by the LCM, you see that 3 will be cancelling the 3, or 3 will cancel 3 to give us 1. So you have 3 times v, which is 3v. 3 has cancelled 3 to give us 1, so you are going to have 1 times 4. That will give us 4 pi r squared h. So you see, as soon as you multiply each term by the LCM and you cancel out, like what we have here, so 3 will cancel 3 to give us 1. 1 times 4 pi r squared h will give us 4 pi r squared h. The fraction is now gone. So we do that to get rid of the fraction. So we've now gotten rid of the fraction, so we can move on. Don't forget that we want to make h the subject. So you make sure that the term that contains h is on one side. Here, the term containing h is already on one side for us. This is the only term containing h. So if you want to make h the subject, we will have to divide through by the other terms that are attached to h. The other variables that are attached to h are 4 pi r squared. So 4 pi and r squared are the other variables or numbers attached to h. The other variables or numbers attached to it are 4 pi and r squared. So we divide each term by those numbers and variables so that you can make h stand alone. So you divide both sides by 4 pi and r squared. When you divide the right hand side here by 4 pi and r squared, it's going to cancel this, so you have h. You divide the left hand side by 4 pi and r squared, you are going to get 3v over 4 pi r squared. So you've changed the subject of the equation from v to h. So h is equal to 3v over 4 pi r squared. Let's move on to the second part of our question. Now, the second part of our question says that we should find h when v is equal to 20, r is equal to 5, and pi is equal to 22 over 7. All we need to do is now substitute these new values into the formula. So where we will see v, you replace it with 20. Where we see r, we replace it with 5. And where we see pi, we replace it with 22 over 7. This is going to give us h is equal to 3 times v, which is 20, divided by 4 times pi, which is 22 over 7, times r squared, and r is 5, so 5 squared. When you punch this on your calculator, you are going to get h is equal to 0.191. Remember, the question said we should leave our answer in 3 decimal places, so you make sure that your answer is in 3 decimal places. That's why I left it as 0.191. If you want to learn how to use your calculator to change numbers to decimal places, watch the videos on approximations that are available on this channel, and you will understand how to change numbers to 3 decimal places and also how to use your calculator to do it. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to consider another example on changing the subject of equations that involve fractions. We are on the topic change of subject. In the previous video, we learned how to change the subject of equations that involve fractions. In this video, we are going to take another example on changing the subject of equations that involve fractions. So let's look at our question for this video. We have: make d the subject in s over t is equal to v plus d over 2. Find d when x is equal to 10, t is equal to 2, and v is equal to 5. So the question for this video is s divided by t is equal to v plus d divided by 2. We said in the previous video that when the expression contains fractions, the first thing you need to do is to identify the fractions. Here, the fractions are s divided by t and v plus d divided by 2. Then after you've identified the fractions, you find their denominators. The denominators are t and 2. So the two denominators in this equation are t and 2. The next step is to find the LCM of the denominators. So find the LCM of t and 2. Now, because the LCM, the denominators, one of the denominators is a variable, in this case t. Because one of the denominators is a variable, the LCM is the product of the denominators. Now, this is what I mean. Because one of the denominators is t, which is a variable, you have to multiply the two denominators and use it as the LCM. So here the LCM we are going to use is 2 times t, which will give us 2t. So whenever you have one of the denominators being a variable, multiply the denominators and use it as the LCM. Okay, so here the LCM we are going to use is 2t. So you find the LCM, which is 2t. The next point is to identify the terms in the equation. Here, what is on the left hand side here is one term. What is on the right hand side here is one term. Because everything here is together, there is no addition or subtraction. Everything here is also together. There is no addition or subtraction separating one term from the other. So we have one term here and another term here. And we've also found our LCM to be 2t. What do? You multiply each term by the LCM. So that is exactly what you are going to do. You are going to multiply each term by the LCM. So you multiply what is on the left hand side by the LCM, which is 2t. You multiply what is on the right hand side by the LCM, which is 2t. So when we do that, we can see that t will cancel t. Here 2 will cancel 2. So we are going to have 2 times x, which will give us 2x. Then because this 2 is gone, here will be divided by 1. We know that v plus d divided by 1 is the same as v plus d. So we have t times v plus d. Because v plus d is a binomial, we are going to put that in a bracket. So we put v plus d in a bracket. So after the cancellation, we are going to have 2x is equal to t into bracket v plus d. Then you move on. We open the brackets. Just as we did when we were solving linear equations, you do the same thing here. So you open the bracket. 2s is equal to t times v, which will give us tv, plus t times d, which will give us td. Okay, the question said we should make d the subject. So you make sure that the terms containing d are on one side of the equation. The terms containing d are on one side of the equation. In this equation, there is only one term containing d, which is td. So make sure that td is on one side, then all the other terms are also on the other side. So in doing that, I will send tv over to this side. So you have 2x minus tv is equal to td. So we have td, which is the term containing d on one side of the equation. What do? We divide through by the term attached to d. The term attached to d is t, or the variable attached to d is t. So you divide the left hand side by t, you divide the right hand side by t. And when we do that, we are going to have, when we do that, you are going to see that this t will cancel this t. So d is going to give us 2x minus tv over t. So you've been able to make d the subject of the equation. D is equal to 2x minus tv divided by t. The question said that we should find the value of d when s is equal to 10, t is equal to 2, and v is equal to 5. So we are going to substitute these new values into our new formula. So wherever we see s, we replace it with 10. Wherever we see t, we replace it with 2, and wherever we see v, we replace it with 5. Now when we do that, we are going to get 2 times 10 minus 2 times 5 divided by 2. When you do this computation on your calculator, you will find out that d is equal to 5. Thank you for watching this video. I hope you enjoyed it. Don't forget to like and subscribe and share this link with others. In the next video, we are going to take another example on changing the subject of equations that involve fractions. In the previous video, we learned how to change the subject of equation that involves fractions. In this video, we are going to take another question on changing the subject of equations that involve fractions. So let's look at our question for this video. The question is, make y the subject in y minus x divided by v minus x is equal to y over v squared. So we are supposed to make y the subject in this equation. Once again, our equation is y minus x divided by v minus x is equal to y over v squared. As we've been doing in the previous videos, when you are being given an equation with a fraction, the first thing you need to do is to identify your fractions. The fractions in this equation are 1 minus y minus x divided by v minus x and y over v squared. After you've identified the fractions, you will see that the denominators of the fractions are v minus x and v squared, as we have here. Now, as we saw in the previous video, we said that whenever one of the denominators or both of them are fractions, in order to get the LCM, multiply the denominators and use it as fractions. So here the LCM we are going to use is the product of the denominators, which is v squared times v minus x. So I'm going to write it as v squared into bracket v minus x. So this will be the LCM that we'll be using, v squared into bracket v minus x, or v squared times v minus x. Okay, so after you found that, the next thing that you do is to multiply the LCM with each term in the equation. So this is one term and this is another term. So you multiply the first term by the LCM, which is v squared into bracket v minus x, and you multiply the second term by the LCM, which is v squared into bracket v minus x, as we have here. Now you do the cancellation. We know that v minus x will cancel v minus x, so you have v squared here will cancel v squared here. So you are going to have v squared times y minus x, so v squared into bracket y minus x. I've explained why we have to put y minus x into bracket, because it's a binomial and it's being multiplied by a single term, which is v squared. Here too we have v minus x times y, so I will put v minus x into bracket and write y outside the bracket. From here you open the bracket and you simplify. So we are going to have v squared times y, which will give us v squared y, v squared times x, which will give us minus v squared x, because there's the negative sign there. Y times v will give us yv, then y times x will give us yx. Don't forget the negative sign, so minus yx. Now when you get here, what do? Remember that if you want to make a certain variable the subject, you group all the terms with the variables in it on one side. So here we want to make y the subject, so we are going to group all the terms with y in it on one side of the equation. Then we will group the other terms on the other side. So the terms with y in it are y squared, v squared y, yv, and yx. So I'll make sure that all of those terms are on one side of the equation. Then the other term, which is v squared x, is on the other side of the equation. So I'm going to take yv from this side and bring it over here. I will take yx from this side and bring it over here. Then I will send v squared x over there. Okay. So that will give us y squared v squared y minus yv plus ys is equal to v squared x. Remember that when a term crosses the equal to sign, the sign of the number changes. When it's negative, it becomes positive. When it's positive, it becomes negative. From here, our next step is to factorize. So I'm going to factorize out the term we want to make the subject, or the variable we want to make the subject. The variable we want to make the subject is y. So I'm going to take y out and put the rest into bracket. So y, if you take y out, this side becomes v squared, here becomes v, and here becomes x. And this is equal to v squared x. As we've been doing all along, when you get to this stage, you divide through by the term in the bracket, or the term attached to the variable you want to make the subject. Here, the variable we want to make the subject is y. The term attached to it is what we have in the bracket, which is v squared minus v plus x. So you divide both sides by v squared minus v plus x. And that is going to give us y into bracket v squared minus v plus x divided by v squared minus v plus x is equal to v squared x divided by v squared minus v plus x. And what do we know from here? We know that this v squared minus v plus x will cancel this v squared minus v plus x, because it's the same thing. So y will give us v squared x over v squared minus v plus x. Now someone may ask, why are we not cancelling this v squared and this v squared? If you watch the video on division of algebraic expressions, you understand why you don't have to cancel this v squared and v squared. So I will advise that you watch that video and you get clear understanding as to why we are not doing this cancellation. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to take another question on changing the subject of equations that involves fractions. We are still on the topic change of subject. In the previous video, we took a question on changing the subject of equations that involves fraction. In this video, we are going to take another question on changing the subject of equations that involve fractions. So let's look at our question for this video. Make n the subject in 1 divided by t is equal to 1 divided by n plus 1 divided by y. Find n when t is equal to 2 and y is equal to 4. Let's deal with the first part of our question, then we'll tackle the next part. The first part says that we should make n the subject. We should make n the subject in the expression 1 over t is equal to 1 over n plus 1 over y. So we want to make n the subject. Now, this is an equation that involves fractions. We said that whenever the equation involves fractions, what do? You identify the fractions. So the fractions are 1 over t, 1 over n, and 1 over y. Then from there, you identify the denominators. The denominators are t, n, and y. Then you find the LCM of the denominators. But we said that when you have variables as the denominators, multiply the variables and use them as the denominators, as the LCM. So because we have variables as the denominators, we are going to multiply them and we will use it as the LCM. So here the LCM we are going to use is going to be t times n times y. This will be our LCM. Now in algebra, we know that we usually don't write multiplication. So t times n times y will be written as t n y. So this is the LCM that we are going to use, t and y. After that, after you found the LCM, as we've done in this case, you identify the terms in the equation. The terms in this equation are 1 over t, 1 over n, and 1 over y. Now, after you have identified the terms, you multiply each term by the LCM. So that is the next thing we are going to do. We are going to multiply each term by the LCM, which is t and y. So you multiply 1 over t by t and y. We multiply 1 over n by t and y as we have here, and we multiply 1 over y by t and y. From here, you do the cancellation. So you can see that t here will cancel t, n will cancel n, and y will cancel y. So in effect, we are going to get ny times 1. Ny times 1 is ny. Because n is gone and this n is also gone, we are going to get ty times 1. Ty times 1 give us ty. Now this y is gone and this y is also gone, so we are going to have tn times 1, which will give us tn. So we have been able to clear all the fractions. Now we can go ahead, group our like terms, factorize, and simplify. So what do? We want to make n the subject. So we make sure that all the terms containing n are on one side of the equation. The terms containing n are ny and tn. So I'll make sure that ny and tn are on one side of the equation. Because ny is already here, I'm going to bring tn over from the right hand side to the left hand side. So that will give me ny minus tn. Ty is already here, so I'll keep it there. From here, I'll factorize out n because that is what I want to make the subject. So I'll factorize n out. When I do that, I'm going to have n into brackets y minus t is equal to ty. I've explained why we have to put y minus t into brackets several times. So I hope that by this time you understand it. Okay, when we get here, what do? The variable we want to make the subject is n. What is attached to n is y minus t. So we have to divide through by y minus t. So we divide the left hand side by y minus t. We divide the right hand side by y minus t. So y minus t here, this y minus t will cancel this y minus t. And we are going to get n is equal to ty divided by y minus t. Once again, someone might may ask, why are we not using this y to cancel this y? If you want to understand why we are not cancelling, go and watch the video on division of algebraic expressions. I explained why you don't have to cancel, or why cancelling this is wrong. If you watch that video, you understand it very, very well. Let's move on to the second part of our question. It said that we should find n when t is equal to 2 and y is equal to 4. We have been able to make n the subject, so all we need to do is to substitute these two values into the new equation. So where we see n, we will replace it with 2. Where we see y, we will replace it with 4. So this is going to give us n into brackets 2 times 4 divided by 4 minus 2, and this will give us n to be equal to 4. Thank you very much for watching this video. I hope you enjoyed the video. See you in the next video, where we are going to solve another example on changing the subjects of equations involving fractions. We are on the topic change of subjects. In the previous video, we solved the question on changing the subject of equations that involves fractions. In this video, we are going to solve another question on changing the subject of equations that involve fractions. So let's look at the question for this video. Make u the subject in y is equal to 1 over 4 ux plus 3ys. So here is our question once again. Y is equal to 1 over 4 ux plus 3yx. This equation involves a fraction. The first thing you need to do is to identify the fraction. And the fraction we have here is 1 over 4. The denominator is 4. Since that is the only fraction in the equation, you are going to use its denominator as the LCM. So the LCM we are going to use will be 4. Now what do we do from here? You multiply each term in the equation by the LCM. I've taught you how to identify terms. So I know that by this time you are conversant with identifying terms in an equation. In this equation, the terms are y and 1 over 4 ux and 3yx. So we have 3 terms in this equation. You multiply each term by the LCM. The LCM is 4. So that is exactly what we are going to do. We will multiply y, which is the first term, by 4. We will multiply 1 over 4 ux, which is the second term, by 4. And we multiply 3yx, which is the third term, by 4. From here, we do our cancellation. We can see that from fractions, we know that 4 here can cancel 4 here. So 4 will cancel itself 1 and cancel 4 here 1. Now, we do the multiplication. 4 times y will give us 4y. 1 times 1 us will give us us. 4 times 3ys will give us 12ys. Once again, if you watch the video on multiplication of algebraic expressions, you will understand why 4 times 3ys is 12ys. I explained that into details there. So I recommend that you watch the video on algebraic expression, especially multiplication of algebraic expressions, and you understand how these multiplications are being done. Okay, let's go ahead and make u the subject in our equation. Our goal is to make u the subject. In order to achieve that, we have to make sure that the terms containing u are on one side of the equation. Luckily for us, there is only one term containing u, so we make sure that that term is on one side of the equation, and that term is us. So we make sure that us stays on one side, then all the other terms will be on the other side. Now I have 4y here. 12ys does not contain u, so I will take it from this side and bring it here. It's positive here, so when it comes to the right hand side, to the left hand side, sorry, it becomes negative. So I'll have 4y minus 12ys is equal to us. Now what do? I want to make u the subject. The variable attached to u is x. What I'll do is that I'll divide both sides by x, such that x can cancel s out, so that I'll get u to stand alone or be the subject of the equation. So I'll divide the left hand side, which is 4y minus 12ys, by x, and I'll divide the right hand side, which is us, by x. Now when I do that, you will see that x will cancel x, so I now have u alone. So I'll have 4y minus 12yx over x is equal to u. So you can see clearly from here that you have been able to make u the subject of the equation. Thank you for watching this video. I hope you enjoyed this video and all the other videos on change of subjects. Don't forget to like and subscribe. In the next video, we are going to look at how to change the subject of the third type of equation. These equations involve squared terms or the square root sign. When that happens, how do we change the subject? See you in the next video and let's find out. We are still on the topic change of subjects. In the previous video, we learned how to change the subject of equations that involve fractions. In this video, we are going to learn how to change the subject of equations that involve square terms or square root signs. So, how do we change the subject of equations that involve square terms or square root sign? So this is going to be type 3. The equation involves a square or a square root sign. What do we do? The first point says that you should clear the square root sign by squaring both sides of the equation. So if there's a square root sign in the equation, what you do is that you clear the square root sign. You first have to remove the square root sign by squaring both sides of the equation. We will learn how to do that. If the variable that you want to make the subject is a squared term or a squared quantity, you take square root of both sides so that that variable can be made the subject. We will also understand how to do that. So the two main things that you need to take note are, if the variable that you want to make a subject is under the square root sign, you square both sides to clear the equation. If the variable that you want to make the subject is a square term, you take square root of both sides to make it the subject of the equation. Now let's take some questions and see how to do this. We have 4 questions here. We will solve the first one in this video, then we will solve the others in the subsequent videos. So let's take the question for this video. Given that t is equal to 2 pi square root of L over G, make L the subject of the equation. Find L if t is equal to 1, G is equal to 9.81, and pi is equal to 3.142. Give your answer in 3 significant figures. Okay, so this is our question. Let's concentrate on the first part. We have been given the equation t is equal to 2 pi square root of L over G, as we can see here, and we are being told to make L the subject of the equation. Now let's look at this question very clearly. You can see from here that we have to make L the subject of the equation, and L is under the square root sign. Because the variable that we want to make the subject is under the square root sign, the first thing we need to do is to get rid of the square root sign. In order to get rid of the square root sign, we will have to square both sides of the equation. What do? We square all the terms on the left hand side and we square all the terms on the right hand side. So we square everything on the left hand side, then we square everything on the right hand side. So we are going to have, what is on the left hand side is t, so t squared. Then we square everything here, so we are going to put everything there in the bracket. We are going to put everything on the right hand side in a bracket because there are more than one. You see, here, because it was only 1, that's why we went away to square it. But here, because there are more than 1, we have to put everything there in a bracket, then we square it. I hope that is clear. So we go ahead with the squaring. Now when you do this, what do? We distribute the square for every number or variable here. So 2 will be squared, pi will be squared, then square root of L over G will also be a square. Now that's what's happening. So we are going to give the square to 2, so 2 squared. We will square pi, so pi squared. Then square root of L over G will also be a squared. Okay, that's what I meant by squaring everything on the left hand side and on the right hand side. So we will square 2, we will square pi, then we will square root of L over G. Okay, let's move on. T squared, so we have T squared, 2 squared, 2 raised to the power 2. We know from indices that 2 raised to the power 2 is 4. Pi squared, so we have pi squared. We also know from indices that whenever you have a number or a variable under a square root sign, let's say s squared, let's say x, square root of x. Sorry, I'm going to write it well so that you get it. Let's say that we have the square root of x. So square root of, okay, let me use a. I think that's easier to write. So we have square root of a, and you squared this. You squared square root of a. The square will cancel the square root sign to give you a. So if you have square root of L over G and you square it, the square is going to cancel the square root sign. So here, this squared raised to the power 2 will cancel the square root sign so that we have L over G. Now this L over G is multiplying what we have here. So we are going to have 4 pi squared times L over G. So whenever there is a number or a term under the square root sign and you squared it, the square root sign will be cleared. So the square will cancel the square root sign. So we now have L over G. Okay, let's continue. We want to make L the subject. We have been able to clear the square root sign. Now we do our multiplication. So t squared is equal to 4 pi squared times L. Since we are going to have 4 pi squared over 1. Any number that stands on its own is over 1. So this one too is over 1. So 4 pi squared times L will give us 4 pi squared L. 1 times G will give us G. Okay, we now have an equation that involves a fraction. We said in the previous videos that whenever the equation involves a fraction, what you do is that you identify the fractions, you find the denominators, then you find the LCM of the denominators. Now the denominator here is G, so that is what we are going to use as the LCM. That's the only denominator here, so that is what we are going to use as the LCM. You multiply each term by the LCM. The LCM is now G, so we multiply the term which is T squared by the LCM which is G. Then we multiply this term here, 4 pi squared L over G by the LCM which is G, in order to clear the fractions. So T squared times G is equal to 4 pi squared L over G times G. Now when you do that, you can see that we will have G to cancelling G, so the fraction is also gone. T squared times G will give us T squared G. Now we have 4 pi squared L because the G and G has cancelled each other out, so we have 4 pi squared L. We want to make L the subject. What is attached to L is 4 pi squared. What do? We divide both sides by the variable or the numbers attached to L. So we divide both sides by 4 pi squared. So 4 pi squared, we will use it to divide what we have on the left hand side. Then we will do the same thing to the right hand side. So you see that 4 pi squared here will cancel 4 pi squared here, giving us L. So L is equal to T squared G over 4 pi squared. So we have been able to make L the subject of the equation. We got L is equal to T squared G divided by 4 pi squared. So we have been able to achieve the first goal, to make L the subject of the equation. The second one said that we should find L when T is equal to 1, G is equal to 9.81, and pi is equal to 3.14. So what do? We substitute these new values into the equation. So wherever we see T, we will write 1. Where we see G, we will replace it with 9.81, and we will replace pi with 3.142. So that's exactly what you're going to do. You have 1 squared times 9.81 divided by 4 times 3.142 squared. Now you punch this on your calculator. So if you take your calculator, you are going to have 1 squared times 9.81 divided by 4 times 3.142 squared. Okay, so it's equal to 0.24845. The number goes on and on. But the question told us to give our answer in 3 significant figures. The question told us to give our answer in 3 significant figures. If you watch the video on approximation, I explained how to correct your answer to 3 significant figures. I also explained how to use your calculator to do it. In this video, I'm going to use the calculator to do so. Watch once again. Okay, so this is our answer. Now, to use your calculator to correct this answer to 3 significant figures, just press on Shift, you press on Mode, you pick the 7th option, which is psi, the significant figures. It's asking you psi 0 to 9, which means that how many significant figures do you want? I want 3 significant figures, so I'll press on 3. So my calculator is now in 3 significant figure mode. Then I'll press the whole expression that we have here once again. So 1 squared times 9.81 divided by 4 times 3.142 squared. You press enter and your calculator rounds it to 3 significant figures for you. So it's 2.48 times 10 to the power minus 1, which is the same as 0.248. So we have been able to use our calculator to round it to 3 significant figures. Once again, if you watch the video on approximation, I explained into details how you can do that manually and how you can also use your calculator to do it. So if you don't understand this, watch that video and it was explained into details there. So we've been able to make L the subject of the equation, and we have also been able to find L when t is equal to 1, g is equal to 9.81, and pi is equal to 3.142. Thank you for watching this video. Don't forget to subscribe to this video by clicking on the subscribe button below. In the next video, we are going to solve another question on changing the subject of equations that involve squares or square root sign. We are still on the topic change of subjects. In the previous video, we learned how to change the subject of equations that involve squares or square roots. In this video, we are going to take another example on changing the subject of equations that involve squares or square roots. Let's look at the question for this video. X is equal to n over m squared plus y. Make m the subject of the equation and find m if x is equal to 12, n is equal to 28, and y is equal to 0. Leave your answer in said 4. So let's concentrate on the first part of the question. We have to make m the subject of the equation x is equal to n over m squared plus y. Now, we can see from this equation that straight away it involves a fraction. What do we do when the equation involves a fraction? You identify the fraction, you find the denominator, you find the LCM of the denominators, you multiply each term in the equation by the LCM. And that is exactly what we are going to do. So here the fraction we have is n over m squared. That is the only fraction in the equation. It means that the denominator of that fraction is going to be our LCM. The denominator is m squared, so our LCM will also be m squared. We have been able to find the LCM. So the next thing we need to do is to identify the terms in the equation and multiply each term by the LCM, which is m squared. X is one term, n over m squared is another term, and y is also another term. So what do? We multiply x by m squared, we multiply n over m squared by m squared, and we multiply y by m squared. So we have m squared times x is equal to m squared times n over m squared plus m squared times y. From here, we can cancel the fractions out such that the fractions will be away from the equation. So m squared will cancel m squared. So we have taken the fractions out of the equation. M squared will cancel itself 1 and cancel m squared here 1. Okay, let's continue. So we are going to have m squared times x. We know from algebra that that is m squared x. Now this m squared is gone, this m squared is gone, so we have 1 times n, which will give us n. Then plus m squared times y. We know from algebra that that one also is m squared y. Let's go to the question again. We want to make m the subject. We want to make m the subject. Now, if you want to make m the subject, what do? We make sure that all the terms containing m are on one side of the equation. The terms containing m are m squared x and m squared y. So we make sure that they are on one side of the equation. So we group them to one side of the equation. Now, because I have m squared x here, I'm going to keep it. Then I will bring this m squared y over to this side. So we are going to have m squared x. This one is positive here. So when it crosses to this side, it becomes negative. So minus m squared y is equal to n, which is already here. Now what do we do from here? We want to make m the subject. So we are going to factorize m squared out, since that is what we want to stand alone. So if you factorize m squared out, you are going to get m squared into bracket x minus y is equal to n. I'm sure that by this time you are conversant with why we are putting x minus y in a bracket. We've explained it all along since we started. So m squared is equal to x minus y. M squared into bracket x minus y is equal to n. Sorry. M squared into bracket x minus y is equal to n. We want to make m squared stand alone. What do we do from here? As we've been doing all along, we divide through by the variable or the numbers attached to what the letter you want to make the subject. The variable you want to make the subject is m squared. What is attached to it is x minus y. So we are going to divide through by that. So you divide the left hand side by x minus y. We divide the right hand side by x minus y. When we do that, this x minus y will cancel this x minus y so that our m squared can stand alone. So we have m squared is equal to n over x minus y. But look at the question again. The question said that we should make m the subject, not m squared. But if you look at what we have done here, we have been able to make m squared the subject. We want m to be the subject, not m squared. And because we want m to be the subject, in the first video on changing the subject of equation that involves squares and square root sign, we said that when the quantity we want to make the subject is a square term, take square root of both sides. Now, because we want to make m the subject, but what we have here is m squared, we are going to take square root of both sides such that the square can cancel the square root sign will nullify the squared here so that we can make m the subject. So that is exactly what we are going to do. We take square root of m squared here, then we take square root of n over x minus y. What you do to the left hand side, you do the same thing to the right hand side. So we take square root of m squared, and we also take square root of n over x minus y. Now, as soon as you do this, you will see that just as we saw in the previous video, the square will cancel the square root sign so that m will give us square root of n over x minus y. So you see that with this, we have been able to make m the subject of the equation. When we got here, you can't stop here because when you leave it like this, you have made m squared the subject of the equation. The question said we should make m the subject of the equation. So when you get something like this, what you do is that you take square root of both sides such that m can be the subject of the equation. Let's move on to the second part of our question. It said that we should find m when x is equal to 12, n is equal to 28, and y is equal to 0. We now have m to be square root of n over x minus y. So what do? We replace n with 28 x with 12 and y with 0, and that's exactly what you're going to do. So m is equal to square root of n, which is 28, divided by x, which is 12, minus y, which is 0. Now this is going to give us square root of 2. The question said that we should leave our answer in said form. And if you watch the video on sets, you understand that square root of 2 is a set. Because the question said we should leave our answer in said form, we are going to leave our answer just like this. So m is equal to square root of 2. Thank you for watching this video. Don't forget to subscribe by clicking on the subscribe button below. Share the link with others so that they can also enjoy this video. In the next video, we are going to take another question on changing the subject of equations that involve squares or square root signs. We are still on the topic change of subjects. In the previous video, we solved the question on changing the subject of equations that involve squares or square root signs. In this video, we are going to solve another question on changing the subject of equations that involve squares or square root signs. We will be solving two questions in this video. Let's consider the first one. P is equal to m plus s squared. Make s the subject of the equation. This example is pretty simple, so we are going to do it straight away. So P is equal to m plus s squared, and we are supposed to make s the subject of the equation. We know that in order to make a quantity or a variable the subject of the equation, we make sure that the terms containing that variable is on one side of the equation, and all the other terms are on the other side of the equation. We want to make x the subject of the equation, so we make sure that the terms containing x are on one side of the equation, and all the other terms are on the other side of the equation. So I will keep s squared on the right hand side here, then I will send m to the left hand side. So this will give us p minus m is equal to s squared. The question said we should make x the subject of the equation, not s squared. So what do? Because x is a square term, we have to square both sides of the equation in order to make x the subject of the equation. So we take a square root of the left hand side and we take a square root of the right hand side. Now when we do that, you will see that the squared will cancel the square root sign so that the x can stand alone or be the subject of the equation. So square root of p minus m is equal to x, or x is equal to square root of p minus m. So we have been able to make x the subject of the equation. Let's look at our second question. Make u the subject of the relation v is equal to 1 over 4 square root of 25 minus u squared. So this is our question, and we have to make u the subject of this equation. Now we want to make u the subject of the equation. Because the variable we want to make the subject of the equation is under a square root sign, what we have to do, we have to square both sides of the equation in order to take the square root away or get rid of the square root or clear the square root. So the first thing you need to do is, if the variable you want to make the subject of the equation is under a square root sign, square both sides of the equation to clear the square root sign. So that's exactly what you are going to do. You square the term on the left hand side, then you square the terms on the right hand side. So we square everything on the left hand side, but that is only v, so we square v, which will give us v squared. Then we have 1 over 4 square root of 25 minus u squared, all of them squared. Okay, so we move on. This means that we are going to square 1 as we did in the previous video. You squared every single variable or number there. So you give the square to 1, so 1 squared. You squared 4, so 4 squared, then times, since there's no sign between them here, it means it's multiplication, times what is under the square root sign, or this whole term here. So square root of 25 minus u squared, you squared that whole thing too. Okay, let's move on. This will give us v squared is equal to 1 squared is 1, 4 squared will give us 16 times Since this is a square root, as soon as you square it, you see that the square is going to cancel the square root. The square will cancel the square root, so that you will get what is under the square root sign, which is 25 minus u squared. Okay, let's move on. Now we have this as a fraction. We have 1 over 16 as a fraction. How do we get rid of fractions? You multiply through by the LCM. The LCM here is 16. So we are going to multiply the left hand side by 16 and the right hand side by 16. The left hand side is v squared, so 16 times v squared. The right hand side is 1 over 16 times 25 minus u squared, so 16 times 1 over 16 times 25 minus u squared. When you continue with the simplification, you will see that you have 16 times v squared will give us 16v squared. Now this 16 will cancel this 16 to give us 1 here and 1 here. So we will have 1 times 25 minus u squared, which will give us 25 minus u squared. Remember once again that we want to make u the subject of the equation. So what do? We make sure that the terms containing u are on one side of the equation, then all the other terms are on the other side of the equation. Look at something here. U, the term containing u is negative. I want it to be positive. I want the term containing u to be positive. So I will send this u here to the left hand side. Then I will bring 16v squared over to the right hand side. So this will give us, u is negative here, so when it goes there it becomes positive. So u squared is equal to 25 is already here, which is positive. 16v squared is positive. When it crosses to this side, it becomes negative. So we have u squared is equal to 25 minus 16v squared. I now have the term containing u on one side of the equation, but unfortunately it's giving me u squared. The question said we should make u the subject of the equation, not u squared. So what do? We take square root of both sides of the equation. When we take square root of both sides of the equation, the squared can cancel the square root sign so that we will be able to obtain u. So I'll take square root of the left hand side, then square root of the right hand side. And this is going to give us u is equal to square root of 25 minus 16v squared. So from here to, we have been able to make u the subject of the equation. Thank you for watching this video. Don't forget to subscribe to this channel for more videos. Share the link with others so that they can also enjoy the videos. In the next video, we are going to take questions on changing the subject of equations that involves higher roots or higher powers. We are still on the topic change of subjects. In the previous video, we solved an example on changing the subject of equations that involve squares or square root terms. In this video, we are going to take a question on changing the subject of equations that involves higher powers or roots. So let's look at it. Change equations involving higher powers or roots, and that is the fourth type. That is the last type of equations we will be considering. Now, what do we mean by higher powers or roots? In the previous equations, you saw that we were considering square roots and squares. But in these types of examples, for example, if you take the first one, it contains a fourth root. So you will be considering third roots, fifth roots, fourth roots, and the above. So the roots that you'll be considering will be more than what we were considering in the previous example. In the previous example, we were considering just the square root. Here we're considering third root, fourth root, fifth root, and above. In the same way, in the previous examples, we were considering squared terms. Here we will be considering cube terms or terms raised to the power 3, cubic terms. We will be considering terms raised to the power 4, terms raised to the power 5, and above. So that is what we mean by higher roots or higher powers. So we have 3 questions here, and we will solve them one after the other. We will solve the first one in this video, then we will solve the others in the subsequent videos. So let's look at our question for this video. Make x the subject in y is equal to a over x minus b all raised to the power 1 over 4. So this is a question. Y is equal to a over x minus b all raised to the power 1 over 4. We know from indices that this is the same as y is equal to the fourth root of a over x minus b. So this question here can also be written as this: y is equal to the fourth root of a over x minus b. So in the previous examples, we are considering square roots. Here we're considering third root and fourth roots and fifth root and so on and so forth. That's what we mean by higher roots. Okay, so how do we solve this question? Y is equal to a over x minus b square root of raised to the power 1 over 4, or fourth root of a minus x over b. The first thing we need to do is that we have to make sure that we get rid of the roots. So we have to make sure that we get rid of this fourth root, this 1 over 4, we get rid of it. And how do we do that? Because it is fourth root, you are going to multiply the 1 over 4 by 4. So if it were to be fifth root or 1 over 5, you multiply it by 5. If it were to be the sixth root or 1 over 6, you multiply it by 6. So I hope you get the trick now. Because this is fourth root, you are going to multiply it by 1 over 4. Once again, I will say that if the question gives it to you like this, you have to write it in this way in order to make the solution simpler for you. So if it were given to us as y is equal to the fourth root of a minus x minus b, it is always simpler to write it like this. Here it was given to us this way, so you go straight ahead and solve it. Okay, so as I said, because we have fourth root or 1 over 4, you have to multiply it by 4. So you multiply 1 over 4 by 4. When you do that, you see that the 4 will cancel 4 to give us 1. So you've gotten rid of the fourth root. But don't forget that what you do to the left hand side, you do the same thing to the right hand side. Now this 1 over 4 is raised to the power and you multiply it by 4. That means is that you have to raise what is on the other side also to the power 4. Here the other side is the left hand side. So because you are multiplying this by 1 over 4 and this 1 over 4 is raised to the power, you have to raise what is on the left hand side to the power 4. What is on the left hand side is y, so you raise y to the power 4. So y raised to the power 4. Now as soon as we do this, you can see that 4 will cancel 4. So what is on top here now, the whole thing here now becomes 1. Anything raised to the power 1 is the same thing. So we are going to have y is equal to a over x minus b raised to the power 1, which is the same as a over x minus b. So this is going to give us y is equal to a over x minus b. So we've gotten rid of the roots or the fourth root. Now let's go ahead and make x the subject. We want to make x the subject, but we have a fraction here. What do we do when we have fractions? The first thing you need to do is to identify the fraction, which in this case is a over x. Find the denominator, the denominators, and the LCM of the denominators. The only denominator we have here is x. So after you've done that, you identify the terms and you multiply each term by the LCM. The terms here are y exponent 4 is then a over x and b. So you multiply each term by the LCM. So you multiply what is on the left hand side, which is y exponent 4 by x, which is the LCM, then equal to a over x by x, which is the LCM. Then you go to the last term, which is b, you multiply by x, which is the LCM. When you do that, you can see that x will cancel x, so we have 1 1 here. So the fraction is also gone. We've cleared the fraction. So x times y exponent 4 will give us x y exponent 4. We've cancelled these ones, so we have 1 1 times a will give us a, x times b will give us xb. Don't forget the minus sign, so minus xb. We want to make x the subject. That is what we are interested in. So what do? We make sure that all the terms containing x are on one side of the equation. So I'll bring minus xb from this right hand side to the left hand side, and that will give us xy exponent 4 plus xb is equal to a. I want to make x the subject, so I'll factorize x out. If I factorize x out, I'll get x into bracket y exponent 4 plus b is equal to a. I know you are now conversant with why we are putting y exponent 4 and b in a bracket. So x into bracket y exponent 4 plus b is equal to a. What do we do from here? We divide both sides by what is attached to x, the variable we want to make the subject. What is attached to x is y exponent 4 plus b. So we divide the left hand side by y exponent 4 plus b. We divide the right hand side by y exponent 4 plus b. And you can see that y exponent 4 plus b will cancel y exponent 4 plus b. So our x is equal to a over y exponent 4 plus b. So we have been able to make x the subject of the equation, and x is equal to a over y exponent 4 plus b. Thank you for watching this video. Don't forget to like and subscribe. You can subscribe by clicking on the subscribe button below. In the next video, we are going to solve another example on changing the subject of equations that involves higher roots or higher powers. We are still on the topic change of subjects. In the previous video, we learned how to change the subject of equations with higher roots or higher powers. In this video, we are going to take another question on changing the subject of equations with higher roots or higher powers. Let's look at our question for this video. Make x the subject in Q is equal to 2a divided by b plus 7c divided by d x exponent 3. We have to make x the subject in this equation here. This equation does not involve roots, so there is no way we are going to take square root or cube root or any of those things. Here we have x exponent 3 attached to d, and we are supposed to make d the subject. So we go ahead and we simplify as we've been doing all along. This equation involves a fraction. The fractions are 2a over b plus 7c divided by d exponent 3. So what do? We first identify the fractions as we've done. We find the denominators. The denominators are b and dx exponent 3. We said in the videos on changing the subject of equation that involves fraction that whenever the denominators contains a variable or a letter, you multiply the denominators and use it as the LCM. So here the two denominators we have are b and dx exponent 3. So what we do is that we multiply b and dx exponent 3 and use it as the LCM. So the LCM we are going to use will be b dx exponent 3. So this will be the LCM that we'll be using, b dx exponent 3, because that is the product of the two denominators that we have in the question. So we multiply each term by this LCM. So you have b dx exponent 3 times q, which is the first term, b dx exponent 3 times 2a over b, which is the second term, b dx exponent 3 times 7c over dx exponent 3, which is the third term. We do the cancellation in order to get rid of the fractions. So b will cancel b here, dx exponent 3 will cancel dx exponent 3. Okay, let's go on with our multiplication. b dx exponent 3 times q will give us b dq x exponent 3. If you watch the video on multiplication of algebraic expressions, you understand why the multiplication or the letters were arranged this way. You have to arrange them in alphabetical order. So b dq x exponent 3. Okay, then when you come here, we have dx exponent 3 times 2a. The numbers must come first, so 2 will be first. b dx exponent 3 times 2a will give us 2a dx exponent 3. When you come here to, we have b since dx exponent 3 has been cancelled out, we have b times 7c. So that's going to give us 7bc. So b times 7c will give us 7bc. The number will come first, then you arrange the letters in alphabetical order. We explained all this in the video on algebraic expression. If you watch it, you get that into details. Okay, we are supposed to make x the subject. We have right now we have taken all the fractions out, so we can group our like terms and simplify. Since we are making x the subject, we will group the terms containing x on one side of the equation. So I will keep b d q x exponent 3 here, then I will bring 2ad x exponent 3 over there. So I'll have b d q x exponent 3 minus 2ad x exponent 3 is equal to 7bc. Okay, from here we can factorize x exponent 3 out, since that is what we want to make the subject. So x exponent 3 into bracket b dq minus 2ad will give us 7bc. We've done a lot of this factorization here and in algebra, so you should be conversant with doing it by now. You divide both sides by the group of letters or the variables attached to what you want to make the subject, and in this case that is b dq minus 2ad. So we divide the left hand side by b dq minus 2ad. We divide the right hand side by b dq minus 2ad. When you do that, we can see that this will cancel this as we have done here. So x exponent 3 will give us 7bc divided by b dq minus 2ad. So x is now alone here. But the question told us to make x the subject, not x exponent 3 the subject. Because you are supposed to make x the subject and we now have x exponent 3, what we are going to do is this. We will multiply this 3 by 1 over 3 so that we can cancel the 3 alone for x to stand alone. So that we can cancel the 3 away for x to stand alone. Now you see here is 3. So what we are going to do is that we multiply this 3 here by 1 over 3. 1 over 3. As we've seen here. Now because what you do to the left hand side, you do the same thing to the right hand side. When you come here, you raise what is on the right hand side 2 to 1 over 3. You raise what is on the right hand side 2 to 1 over 3. Here, the 3 is an exponent. So if you multiply it by 1 over 3, you have to raise what you have here 2 to the power 1 over 3. So when you do that, you see that the 3 here will cancel the 3 here so that you have 1. X exponent 1 is the same as x. So you are going to have this 3 here, cancelling this 3 here, so you are going to have x. Then we have 7bc divided by b dq minus 2a, all raised to the power 1 over 3. So what this means is that, let's go back and look at this. What this means is that when you get to this side, when you get here, and we have x exponent 4, you multiply it by 1 over 4 and you raise what you have here to the power. You multiply it by 1 over 4 and you raise what you have here to the power 1 over 4. This is what I mean. Let's say we go to this side and instead of getting 1 over 3, you got 1 over 4 or 1 over 5 or 1 over 6. If it's 1 over 5, you multiply it by 1 over 5 and you raise what you have here to the power 1 over 5. If it's 1 over, here is, if it's 4, if it were to be 4, not 3, you multiply it by 1 over 3 and you multiply it by 1 over 4, sorry, and you raise what you have here to the power 1 over 4. Now because it's 3, we are going to multiply it by 1 over 3 and we raise what you have here to the power 1 over 3. Don't forget that what you do to the left hand side, we do the same thing to the right hand side. So as soon as we do that, x will cancel each other out. So you have x equal to 7bc divided by b dq minus 2ad raised to the power 1 over 3. From indices, we can write this as the third root of 7bc divided by b dq minus 2ad. So if here were to be 1 over 4, you will just write this sign here and change this 3 to 4. If it were to be 5, you write the sign here and change this 3 to 5. So you see that the principles are almost the same in all the roots. If you understand how to solve for one root or power, you can also solve for the other root or powers. Thank you for watching this video. Don't forget to like and subscribe. Subscribe by clicking the subscribe button below in order to get more videos. Share this link with others so that they can also enjoy this video. In the next video, we are going to take another question on changing the subject of equations with higher roots or powers. In the previous video, we solved a question on changing the subject of equations with higher powers or roots. In this video, we are going to solve another question on changing the subject of equations that involves higher powers or roots. This is going to be the last video on the topic change of subjects. Let's look at the question for this video. Make x the subject in y is equal to ax exponent 3 minus b divided by 3c. Okay, so how do we make y the subject in this equation? How do we make x the subject in this equation? The equation once again is y is equal to ax exponent 3 minus b divided by 3c. This equation involves a fraction. So what do? We multiply both sides of the equation by the LCM of the denominators. The only denominator we have is 3c. So we will multiply each term by the denominator, which is 3c. We multiply the left hand side by 3c and the right hand side by 3c. So we have 3c times y is equal to 3c times ax exponent 3 minus b. From here, we know that 3c will cancel 3c. So this will be 1 and here will be 1. 3c times y will give us 3cy. 1 times ax exponent 3 minus b will give us ax exponent 3 minus b. We want to make x the subject. We make sure that the terms or the term containing x is on one side of the equation. So I'll keep ax exponent 3 here, then I'll bring minus b over to the left hand side. And this will be 3cy plus b is equal to ax exponent 3. Once again, we want to make x the subject. So we divide both sides by the term or the terms attached to x or the variable attached to x. The variable attached to x is a. So we are going to divide the left hand side by a and the right hand side by a. And this is going to give us a will cancel a, so we have x exponent 3 equal to 3c plus b over a. We have been able to make x exponent 3 the subject. The question told us to make x the subject. As we said in the previous video, when you get here, what you do is that because this is x exponent 3, or because this is exponent 3, you multiply this side here by 1 over 3. Then you raise this side here to the power 1 over 3. Okay, when you do that, you see that the 3 will cancel the 3 to give us x. So once again, we are multiplying it by 1 over 3 because we are multiplying this side by 1 over 3. This is what I mean. We are multiplying this side here by 1 over 3 because this is exponent 3. So if it were to be exponent 4, we would have multiplied by 1 over 4. If it were to be exponent 5, we would have multiplied by 1 over 5. And whatever you do to the left hand side, you do the same thing to the right hand side. So if, let's say for example, this is x exponent 4, you multiply it by 1 over 4 and you raise what you have here to the power 1 over 4. If it were to be x exponent 5, you would have multiplied by 1 over 5 and then you raise what you have here to the power 1 over 5. This time is 1 over 3. So we multiply this here by 1 over 3 and you raise what we have here to the power 1 over 3. So as we saw, 3 will cancel 3, so we have x is equal to 3cy plus b over a exponent 1 over 3. We know from indices that this can also be written as the third root of 3cy plus b all over a. 3cy plus b all over a. So x is equal to 3cy plus b all over a exponent 1 over 3 can also be written as 3 square root of 3cy plus b all over a. We know this from indices. If you watch the video on indices, you understand this into details. Thank you for watching this video and all the videos on change of subjects. This is the end of the topic change of subjects.